Hi, I am Khalid Mosharraf Mukut, currently doing my PhD in mechanical engineering. My advisor is Dr. Samesh Roy. In this presentation, I am going to talk about my research, that is understanding soot formation in combustion devices. Soot or black carbon is composed of tiny carbon particles and forms during incomplete combustion. The knowledge about soot formation is very important because it can heavily impact radiative heat transfer and contribute to global warming. It affects the environment in two ways. Number one, by absorbing sunlight and directly heat the atmosphere. Number two, by accumulating in the snow surfaces that results in higher melting rate of Arctic ice. In the right hand side figure, I am showing a global map of temperature increase because of soot alone between 1880 and 2002. As you can see, the rise in temperature is significantly higher in the Arctic regions. Even with an increase of 100 parts per billion of soot, the rate of ice melting can increase by double or even more if we consider positive feedback effect. The structure and aging of atmospheric soot can also influence the amount of radiative forcing. Therefore, it is very important to understand how these soot particles form, grow, age, and influence the atmosphere. Now let's talk about the soot formation process. Soot formation is a complicated process. How these soot particles emerges from the gaseous species in flames and develops into fractal-like aggregates is not still properly understood. In a combustion scenario, soot formation starts with gas phase precursor molecules which combines together to form the first soot particles. The initial particles then go through events like surface growth, coagulation, sintering, and oxidation, and finally becomes the fractal-like aggregates of larger soot particles. The goal of my research is to understand soot formation steps and model soot formation, keeping the size and morphology informations consistent with the theory. For our work, we are working on developing a stochastic model for soot formation where we can retain more information about soot morphology and composition. The initial algorithm is presented here. The algorithm lets us track individual soot particles using stochastic parcel method. The disadvantage of this kind of approach is very high computational expense. Making the soot model more efficient and computationally accessible is the next phase of my research. We have done some preliminary work regarding this soot model. During our study, we observed that the soot morphology and structure can vary with different time and location in the combustion chamber of an engine. For our future work, we are considering conducting some molecular dynamic study where we can study the soot formation behavior during nucleation and observe the actual change in composition and evolution of soot structure from a first principle point of view. Thank you for listening to this presentation. If you have any question, feel free to shoot an email at me. You can also visit our lab website to learn the updates about this research. Thank you.